Today we are going to talk about quadratic functions. Before talking about quadratic functions, let's recall some basic function notation. Here function f is defined as f of x equals 2x squared plus 3x plus 5. F is the function, x is the input, f of x is the output, which is given by this formula. This is read as f of x or f at x, which means f is evaluated at x. F of x is not f times x, so this is important. So we'll look at an example. So f of x is given as 2x squared plus 3x plus 5. Find f of 3. So this is very simple. You just replace x with 3, and you have to do for all the instances of x, and then you simplify it, then you get the answer for f of 3. What about f of x plus 3? So here also you replace x with x plus 3, then you simplify, but when you're simplifying you have to be careful with this x plus 3 squared. So this is actually x plus 3 times x plus 3, so you have to either use the FOIL method and expand it, or you have to use the standard formula for expanding a plus b squared. So you have to remember that formula. So it will be x squared 2 times this, which is 6x plus 3 squared. Okay, and here when you distribute this you get 3x plus 9 and plus 5. So here you cannot just distribute this square, because it's not something like this. Okay, this is not multiplying by 2. This is x plus 3 times x plus 3. Okay, so this this 2 is not the same as this 3. Okay, and then you simplify it, and when you are simplifying you have to again distribute this 2, and you have to simplify this thing, and you get this. So this is f of x plus 3. So f of 3 is not 3 times f. In other words, f of 3 and 3f, which is 3 times f. So this is 3 times f. This is f of 3. So these are not the same thing. Okay, this is f of 3 and this is 3 times f. And this is not equal to x squared plus 3 squared. You also have this term. Okay. Okay. Now we come to quadratic functions. So a quadratic function is a function of the form f of x equals ax squared plus bx plus c, where a, b, c are real numbers, with a being not equal to 0. So if a is 0, then this thing will vanish, and this will be just bx plus c, which is a linear function. Okay, so it's not a quadratic function. So for it to be a quadratic function, a has to be non-zero. So a quadratic function is a polynomial whose greatest exponent is 2. The shape of the graph of any quadratic function is called a parabola. So we'll see what a parabola is. So characteristics of the parabolic graph of quadratic function changes when we change the values of a, b, or c. Okay. Quadratic function. So these are some properties of quadratic functions. So when a is positive, the parabola opens upward and the function has a minimum value. When a is negative, the parabola opens downward and the function has a maximum value. Coordinates of the y-intercept are 0, f of 0. So on the y-axis, the x coordinate is always 0, and if alpha and beta are real solutions of the equation f of x equals 0, coordinates of x-intercepts are alpha 0 and beta 0. So so this alpha and beta has to be real. Okay, they have to be real. So if they are complex, then there won't be any x-intercepts, so the graph will not touch the x-axis. Okay, so if the roots of this equation are not real, that means if they are complex roots, then the graph will not touch the x-axis. Okay, so if f of x has no real solutions, then the graph of f has no x-intercepts, so it will not touch the x-axis. Okay, so this is a graph like that. So this so if you solve f of x equals 0, you will have complex roots. Okay, so you will have complex roots. So if you use the quadratic formula to solve f of x equals 0, you'll get complex roots. So so this graph does not touch the x-axis. Okay, so this point is called the vertex, and this is the y-intercept, which is f of 0. You get 4, and no x-intercepts. Therefore, this so f of x equals 0 will not have any real roots. Now this function is a bit different. So this has f of x equals negative x squared. So a is negative, so it opens downward. So here a was positive, so it opened upward. Okay, it opens upward. So if it's negative, then it opens downward, and it has a maximum value. So if the a is positive, it has a minimum value. Okay, so if a is positive, it opens upward and it has a minimum value. If a is negative, it opens downward and has a maximum value. Okay, so we will discuss how to find the coordinates of the vertex later in this video. Standard form of a quadratic function. So a quadratic function, f of x equals a x minus h parentheses squared plus k, where a is non-zero, h and k are real numbers, is said to be in standard form. So what is important about standard form is it can be readily used to find the coordinates of the vertex and the maximum or the minimum value, and where that maximum or minimum occur. And any quadratic function can be converted to the standard form and vice versa. So it's just an equivalent way to express the same function. So standard form of a quadratic function is not a different function. So if you convert a quadratic function to standard form, it's the same function expressed in a different way. So they are actually equal. Okay. So again here, when a is positive, the parabola opens upward and the function has a minimum, and when a is negative, the parabola opens downward and the function has a maximum value. So the coordinates of the vertex would be hk, and the axis of symmetry would be x equals h, and the maximum minimum value would be k. These, with some additional information, can be used to sketch the graph of a quadratic function. So now let's see how to sketch graphs of quadratic functions. So graphing f of x equals a x minus h squared plus k. So first determine whether the parabola opens upward or downward. If a is positive, it opens upward. If a is negative, it opens downward. Determine the vertex, which is just hk. Find any x-intercepts by solving f of x equals 0. And remember, if this equation has complex roots, the parabola will not touch the x-axis. Okay, and find the y-intercept by calculating f of 0. Okay, so on the x-axis, y-coordinate is 0, and on the y-axis, x-coordinate is 0. Okay, so the last step is to plot the intercepts, the vertex, and some additional points as needed, and then connect these points with a smooth curve that is shaped like a parabola. Okay, so in exams we will not like deduct marks if the graph is like not perfect, like it can be like bent or anything, but if you like find the intercepts and all the necessary points, if you follow these steps and find all the things and find all these things correctly, then you will get almost full credit for that problem. Okay, so the shape does not need to be like perfect. It only needs to be a sketch. So example 1, graph the quadratic function f of x equals 2x minus 2 squared minus 18. So how are we going to sketch the graph of this function? So identify a, h and k. So a is 2, h is again 2, and k is negative 18. Now to identify a, h and k, you have to convert this into the exact standard form. That means you must have positive something. So you have to like rewrite this as positive of negative 18. Okay, here it's not a problem, but here you have to write it like this. Then this thing is k. Okay, now since a is positive, the parabola opens upward and the function has a minimum. Vertex is 2, negative 18. To find x-intercepts, you have to solve this equation. So when you solve this, you get negative 1 or 5. So the x-intercepts are negative 1, 0 and 5, 0, or negative 1, 5. To find y-intercepts, you just evaluate f of 0. So x is 0. On the y-axis, x is 0. On the x-axis, y is 0. So you plug in 0 for x, then you simplify. So here 0 minus 2 is negative 2, and negative 2 squared is positive 4, and 2 times 4 is 8, and negative 18 is negative 10. So the y-intercept is 0, negative 10. So this is some notes about simplifying these things. So if you have something like this, and you take the square of a negative number, it becomes positive, because negative 2 times negative 2 would be positive 4. Okay, and 2 times 4 is 8. And here again, negative 2 squared would be positive 4, and when you multiply it by negative 2, you get negative 8. And here, square of 2 is 4. Square of positive 2 is positive 4. And when you multiply it by negative 2, you get negative 8. So for in both these cases, you get the same answer. Okay, you get the same thing. Okay, for negative 2 and 2. Okay, you get, for both you get negative 8. Okay, so this is just some notes about simplifying these things. Okay, so now we have to draw the graph. We have found all the necessary information. So if you find all the necessary information correctly, you can get almost all the credit for that problem. So these are the things that are important. Like if you can find, okay, this is the vertex, it has a maximum, and these are the x-intercepts and these are the y-intercepts, then we know you know the material. So the graph is this. So if you see, the vertex is 2, negative 18. So let's see whether that's correct. so this is 2 negative 18. So okay, and x-intercepts are negative 1 and 5, and y-intercept was negative 10. Okay, this negative 10 and negative 1 5. Okay, negative 1 5. Okay, so to find this you have to solve this equation. So if it's in standard form, it's very easy to solve. Okay, example 2. Graph this function. So here this is negative, a is negative, so it will open downward and it will have a maximum. Okay, so again be careful, you have to write this in the exact standard form. So you have to have minus something, but here you have plus 2, so you have to rewrite it as rewrite it like this. So h should be negative 2. Okay, so when you have positive 2, h should be negative 2, because it's x negative negative 2. Okay, because in standard form it is x minus h. So to find h, you have to write it as x minus something, and then you can identify h. Okay, so h is negative 2 and k is 9. Now a is negative, so parabola opens downward and the function has a maximum value. Vertex is negative 2 9. So find y-intercepts by solving this. Okay, so so x-intercepts, so you can find x-intercepts by solving this, and x-intercepts are 1 and negative 5. Okay, so on the x-axis y is 0. Okay, so for y-intercept you just calculate f of 0, so you get so when you simplify this you get 5. Okay, so you plug in 0 for x, then 0 plus 2 is 2, 2 squared is 4, but you have a negative sign, so it's negative 4, and plus 9 negative 4 plus 5. Okay, okay, so now draw. So this is the graph. So you had vertex negative 2 9, so negative 2 9, and these are 1 negative 5, 1 negative 5, and this is 0 5, so the y-intercept is 5. Okay, so 0 5, so coordinates are 0 5, and this has a maximum value. Okay, and the maximum occurs at x equals negative 2. So in practical applications, finding maximum and minimum is very important. Okay, so now the important thing is how to convert a quadratic function that is not in standard form to standard form. So this is very important to when you want to find maximum minimum values and where they occur. Okay, so now when you convert a quadratic function to standard form, it's still the same function in a different way, in a different kind of expression, but it's the same value. If you plug in x values, you get the same thing. So we'll see how to convert this function into standard form. Okay, so this method is called completing the square. So you have f of x equals ax squared plus bx plus c, and you take out a as a factor, although a is not common. So when you take it out, you get x squared, and this gets divided by a, this also gets divided by a. Okay, so you have division by a, so this can be done because a is non-zero. So when you distribute it back, you get the same thing. Okay, now this is the tricky step. Okay, so 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 these two terms, so this thing is actually equal to this thing. Okay, so if you try to so if you expand this and simplify, you get this. So this is equal to this. Okay, so what happens is when you square this, you get x squared, then you get 2 times this, so 2 and 2 will cancel, so you get b over a times x, and you will get b squared over 4a squared, which we don't need here. So you have to subtract that. Okay, so you have to subtract that. So when you subtract that, you get these two terms. Okay, so you get these two terms when you subtract this from this, and then you have this plus c over a. So we are actually replacing this by this. So we can replace this by this thing, because these two are equivalent, because they are the same thing. This thing and this whole thing are the same. They are equal. They are equivalent. It's the same thing expressed differently. Okay, it's the same thing expressed in a different way. So if you simplify this, you get these two terms. Okay, so expand this and see. So then you take out negative, then you get this. So negative, negative, positive, positive, negative, negative. Then you take the common denominator, then you get this 4a squared, so you have to multiply this by 4a, because when you divide 4a squared by a, you get 4a, so you have to multiply c by you have to multiply negative c by 4a, so you get negative 4ac. Now you distribute a back in. You distribute a back in, so you multiply by a. So here you took out a, now we are sending it back. So a times this, a times that, so this a squared becomes a, because when you multiply this thing by a. Okay, so here also this thing also gets multiplied by a, so you have a here. Okay, this also got multiplied, so this a squared became a. Now this is the standard form, but to identify a, h and k, it has to be exactly in the exact standard form. So here you need negative and here you need positive. So now we can identify a, h and k. So a is a itself, h is negative b over 2a, and k is negative b squared minus 4ac over 4a. Okay. Okay. So when you do the completing of when you complete the square and get this expression, this is the maximum or the minimum value of the function, and the function attains that maximum or the minimum when x equals negative b over 2a. Okay, and the whether it has a maximum or the minimum, it will depend on whether a is positive or negative. When a is positive, it's a minimum. When a is positive, it's a minimum. When a is negative, it's a maximum. Okay, so it goes the like the other way. Okay, so when a is positive it's a minimum, when a is negative it's a maximum. So uh, so from this you can find the coordinates of the vertex as well. So it's where you get the maximum or the minimum and the maximum or minimum value. Okay, that's the coordinates of the vertex. Okay, so this is what we discussed. So these are all what we discussed. Okay, so solving this equation for x, we can find the x coordinates of the x intercepts, and when we solve this equation for x, you will get the quadratic formula. Okay, and x intercepts will exist only if you have real solutions for x in this equation. Okay, so if you get real solutions for x when you solve this equation, then you will have x intercepts. Otherwise, the function will not touch the x-axis. The graph of the function will not touch the x-axis. Okay, if the solutions for x in this equation are not real. Okay, you get the quadratic formula, so try it as an exercise. And x-intercepts are, so this is the quadratic formula, plus or minus, so they will give you two x-intercepts, and x-intercepts will exist only if the equation has real solutions. Okay, so if this is negative, no x-intercepts. So x-intercepts will exist if and only if b squared minus 4ac is non-negative. Okay, so that's what we discussed earlier as well. So there won't be any x-intercepts if b squared minus 4ac is negative, because this equation will have complex roots. It will not have real roots. So if it does not have real roots, then no x-intercepts. It will not touch the x-axis.